Hello everyone. Today we shall be going through a mathematical process called proof by induction. So this is a process that we use to prove that a certain mathematical statement is true for integers above a certain value that we shall note as n0 in this case. For example, let us take an example of a mathematical statement such as 2 to the power n is always greater or equal to n plus 1 for all integers, for all n greater than or equal to 1. So this is a mathematical statement and we are trying to prove that it is greater for all values of n greater than 1, that this statement is true. So to use proof by induction, first thing we have to do is this first step which we call the base case. We have to prove the base case. So basically, if we take the first step, the base case is to prove that for p n0, this is true. So if we take this example, basically we need to prove that 2 to the power 1 is greater or equal to 1 plus 1. That is 2 greater than or equal to 2. So this is true. So therefore that is the first step, and we have basically proven that the base case is true. Then we have to assume. So the second step, which is called the inductive step. The second step is to prove that, basically to assume that pk, where n is equal to k, that this particular case is true. We first assume that this is true and use this assumption to prove that pk plus 1 is true if pk is true. So if we can prove that pk plus 1 is also true, that means for all integers above that base case, for all integers n above n0, this statement is entirely and universally true. So basically how this happens is, if we are able to prove that for the base case this is true, and then for pk if it is true, then for pk plus 1 also it is true, that means that for all values after n it's true, because if k was equal to basically n0, we had already proven that it's true. That means for k equals n0 plus 1, there too it is true, because we proved it for k plus 1, this scenario. Therefore it keeps going for n0 plus 1 and all the way up to the infinity. For all of these integers, this statement is true. So that is what we call proof by induction and the basis of this entire process. To understand this concept more clearly, let us take this example. So here we have the statement that we need to prove, and we need to prove it for all integers n greater than 1. So first we need to define and prove the base case. So the first step is to consider n equals 1. And for n equals 1, we know that 2 to the power 1 greater than or equal to 1 plus 1. So that is basically 2 greater than or equal to 2. So this statement is clearly true. So we have proven the base case. Next step, step 2, is the inductive step. So here basically we have to consider that n equals k is true. So this is an assumption. Assuming this, next we have to prove that n equals k plus 1 is true. So based on this assumption, we can say that 2 to the power k is greater than or equal to k plus 1. So we are assuming this particular statement. Now using this, we are going to prove that this particular statement for n equals k plus 1 also it is true. So For that to be true, basically what we are trying to prove is that 2 to the power k plus 1 greater than or equal to k plus 1 plus 1, that is equal to k plus 2, that this is true. So basically 2 to the power k plus 1 is equal to 2 to the power k into 2. So this particular equation, inequality, if we take it and multiply both sides by 2, we get 2 to the power k into 2 greater than or equal to 2k plus 2. So since we have assumed that this is true, obviously this 2 is true. So that means that 2 to the power k plus 1 is greater than or equal to 2 to the power k plus 2. And it is quite intuitive and it's a well-known fact that 2 to the power k, 2k plus 2 is greater than k plus 2. So if k plus 2 is less than 2k plus 2, obviously k plus 2 is less than 2k plus 1. Therefore, we can write that 2 to the power k plus 1 is greater than or equal to k plus 2. And this condition is what we need to prove, that the previous statement is true for n equals k plus 1. So now we have proven for n equals k plus 1, and we have proven for the base case, and therefore we can clearly say that this statement is true, and that for all integers n greater than 1, this statement 2 to the power n greater than or equal to n plus 1 is true. Let us do another example to get a more thorough understanding of this concept. Consider this statement. So basically here we need to follow the same steps. First step being that we have to prove the base case. That means first step is to prove this statement for n equals 1. So for n equals 1, 8 to the power 1 minus 1 is equal to 7. We know that 7 is obviously divisible by 7, and therefore this case is true. Next, step 2. That's the inductive step. Here basically we have to assume that the case for n equals k is true. Which basically means that 8 to the power k minus 1 is equal to 7m, where m is some integer, positive integer. Assuming that this is true, next we need to prove that for n equals k plus 1, this statement is true. So let us consider this case. For n equals k plus 1, we can write 8 to the power k plus 1 minus 1 equals 8 into 8 to the power k minus 8 plus 7. So this can be written as, taking 8 out, factoring 8 out, we have 8 to the power k minus 1 plus 7. This is equal to 8 into 7m. Since we know that this is divisible by 7 due to our previous assumption, and then taking 7 out by factorization, we have 7 into 8m plus 1. So this is obviously divisible by 7, and therefore we have proven for the case where n equals k plus 1, this statement is true. Since it's true for the base case and it's true for n equals k plus 1, that means it's true for all values of n greater or equal to 1. I hope you understood and could grasp this concept of proof by induction, since it is a very important mathematical concept. If you have any questions, please feel free to post them in the comment section. Thank you.